Hello everyone. Today we are going to deal with DC machines and batteries, and myself J Vinay Kumar. In the previous presentation we have already learned about the various characteristics, that is the electrical and mechanical characteristics of DC series and shunt motors. And in this presentation we are going to learn about the electrical and mechanical characteristics of DC compound motors. And we will be also learning about the applications of DC motors. Now let us learn about the characteristics of DC compound motors. We already know that these DC compound motors are of two types. One is long shunt DC compound motor or cumulative compound motor, and short shunt DC compound motor. In long shunt DC motor, the shunt field winding will be connected across the armature and also the series field winding. Whereas in a short shunt DC motor, the shunt field winding will be connected in parallel to only armature. And we know already that These DC compound motors have both the series and shunt field windings. If when the series field excitation helps the shunt field excitation, that means when series flux adds with the shunt field flux, then the motor is said to be cumulative DC compound motor. And if this series field winding flux opposes the shunt field winding flux, then such motors is said to be differential DC compound motor. Now first let us see about the characteristics of the cumulative DC compound motor. In this, the first two characteristics is the electrical characteristics, and these characteristics are drawn between the armature torque and armature current. And we know the torque equation of a motor, DC motor, that is TA is directly proportional to phi means flux and IA means armature current. But in a DC compound motor, the armature torque equation will be TA is equal to K into phi SH plus phi SC into IA. We already know that in a DC compound motor, there will be two fluxes produced by two field windings. And when the load increases, the flux due to series field winding, that is phi SC, increases, and this causes the torque greater than it have been with shunt field winding alone. And if the series field winding flux is stronger than the shunt field winding flux, then the torque current characteristics will be same as a series motor. And if the shunt field winding flux is stronger than series field winding flux, then the torque current characteristics will be same as the shunt motor characteristics. Means here we should know which flux is dominating. If it is series flux, then the characteristics will be as series motor characteristics, and if it is shunt field flux is stronger than the other, then the characteristics will be same as shunt motor characteristics. Now let us see the other characteristics, which is nothing but mechanical characteristics drawn between the speed n and the armature torque T A. And we know that when the load increases, the torque and the armature current also increases. But the series increase in flux due to series field winding causes the speed to fall, but not so rapidly as DC series motor, because of the constant flux produced by the shunt field winding. And because of this shunt field winding, speed will not become exclusively high, and due to the series field winding, the cumulative compound motor will be able to take the heavy loads. By varying this shunt field MMF and series field MMF, we can acquire the required speed torque characteristics. This is the armature current versus armature torque curve. On y-axis, we represent the armature torque, and whereas on x-axis, we represent the armature current. And if we draw a curve for the shunt field flux, then it will be linear, which we have already studied in the characteristics of DC shunt motor. There, the characteristics will be linear because TA is directly proportional to IA. And whereas for a series field winding, the flux will be, the curve will be like this. And this is the differential compound motor, nothing but it is the short shunt compound motor. There the series flux opposes the shunt flux. Whereas in a cumulative compound motor, the series flux aids the shunt flux. The characteristics will be as shown with blue line. And the dotted line represents the rated speed. Now let us draw the characteristics curves between speed n and armature current IA. Here on y-axis represent speed n, and whereas on x-axis represents the armature current. And if we draw a curve between these, it will be like this, represented by a green line. And here the dotted line represents the rated speed. But in practical, sorry, for a series field, it will be as shown in the blue line. For a differential compound motor, the characteristics will be as shown with the red line, and the blue line indicates the characteristic curves of a cumulative compound motor. Now let us see the characteristics between N versus TA. Here we x-axis represents the speed and y-axis represents the armature torque. For a shunt field winding shunt field motor, it will be speed will be reducing slightly, whereas for a series field the characteristics will be represented as the blue line, and this dotted line represents the curve for the differential compound DC motor, and the thick blue line represents the characteristics of cumulative compound motor. Now let us see various curves for differential DC compound motors. In that, the first one is the electrical characteristics. These are the characteristic curves drawn between the armature torque and the armature current. And in this type of differential DC compound motor, the series field opposes the shunt field flux, and when the load increases, the net flux decreases, and this causes the torque to be less than it would have with shunt field winding alone. And the other one is the mechanical characteristics, and these characteristics are drawn between the speed n versus armature torque. And here when the load increases, we know that the net flux gets decreased, or the motor speed remains constant, or even increasing with increase in the load, because the speed n is inversely proportional to the flux phi. And it can be designed to give an accurately constant speed under all conditions. And this motor has limited applications. This can be used in experimental and research work. Now let us see the applications of various DC motors. First of all, let us recollect the various DC motors. We know that the DC motors are classified into two types based on excitation, that is separately excited DC motor and self excited DC motor. And these self excited DC motors are again classified into three types based on the field winding connection. When the field winding is connected in series with the armature and load, then such a type of motors are called as DC series motors. And when the shunt field winding are connected in parallel to the armature and load, then such type of motors are known as DC shunt motors. And this and the other one is DC compound motors. These compound motors are classified into two types, and these motors have both the series field winding and shunt field winding, and this classification is one is DC differential compound DC motor. In this, the series field winding flux opposes the shunt field winding flux, and the other one is cumulative compound DC motor. Here, the series field flux aids the shunt field flux. These are the classifications. Now let us see the applications. First of all, let us see the applications of DC shunt motor. We know that it is a constant speed motor, but in practical its speed varies a little bit when the load is applied, means approximately constant speed. And such a type of DC shunt motors can be used for lathes, means lathe machines. In mechanical workshop we use this lathe machines to perform a job. And line drive shafts drives centrifugal pumps and reciprocating pumps, which are used to pump the water from lower head to the higher head. And the next one is machine tools, blowers, fans, grinders, shapers, woodworking machines, and also we use this shunt machines in small printing presses. So these are the applications of DC shunt motor. Now let us see the applications of DC series motor. We know that the series motors has high starting torque, and due to this high starting torque we use these motors in certain applications such as electric traction or electric locomotives. There we required the main characteristics as high starting torque and rapid transient systems. We also use these DC series motors in tram cars and railway cars, cranes, hoists, and also in elevators and in conveyors. Conveyors means conveyor belts used to transport the material. And now let us see the applications of cumulative compound DC motor. These motors especially have is high starting torque as well as it can also be used with variable speeds. Due to these characteristics, these cumulative compound DC motors are used for shears, punches, elevators, and conveyors, rolling mills, ice machines, printing presses, and air compressors, electric shovels, and metal stamping machines. The last one of this DC motors is the differential compound DC motors. And these motors will give an accurately constant speed at any condition. So these are mainly used for research work and also for experimental works. Okay, from this presentation we have learned about the electrical and mechanical characteristics of DC cumulative compound motors as well as DC differential compound motors. And now let us see a small quiz on this presentation. In that, the first question is, which of the following load will be best driven by a DC compound motor? Option A, reciprocating pumps. Option B, centrifugal pumps. Option C, electric locomotive. Option D, fans. Yes, the answer is reciprocating pumps. Now let us see the next one. A DC shunt motor is found suitable to drive fans because they require option a small torque at startup, a large torque at high speeds, practically constant voltage. Option D, both A and B. As the answer is yes, a small torque at startup and large torque at high speed. So the answer is option D. Now let us see the third one. When a DC cumulative compound motor is loaded then option A is torque increases and speed decreases. Option B is torque decreases and speed increases. And option C is both speed and torque increases. And D is both speed and torque decreases. Yes, the answer is torque increases and speed gets reduced. And the fourth question is, for continuously running rolling mills with intermittent loading, the most suitable DC drive is Option A, DC series motor. Option B, DC shunt motor. Option C, DC differential compound motor. And option D, DC cumulative compound motor. Is the answer is cumulative compound DC motor. Now let us see the last one. In a differential DC compound motor, if the shunt field gets suddenly opened, the motor will first start and then run in opposite direction as a series motor. Option B, run as a series motor but at slower speed in same direction. Option C is run as a series motor in the same direction at high speed. And option D is not work and come to standstill. Because the answer is first start and then run in opposite direction as a series motor. Okay, from this we will be closing this. Thank you very much for listening with this